Welcome now to double angle formulas. In this lesson, we're going to look at working with our double angle formulas. Sine 2 theta, cos 2 theta, and tan 2 theta. Notice for cosine 2 theta, it has three different identities. So for our first example, we're just going to simplify each of the following and then evaluate. 2 times sine of pi over 8 times cosine of pi over 8. We would need a calculator for this normally. However, if you look at the identity for sine of 2 theta, you see we have the 2 sine theta cos theta. So this would be equal to the sine of 2 times pi over 8, which is equal to the sine of pi over 4. And with our special triangles, we note that the sine of pi over 4 is 1 over root 2, or root 2 over 2. B looks like the double angle formula for tangent, so therefore this equals the tan of 2 times pi over 6, which is the tan of pi over 3. And using again our special triangles, tan of pi over 3 is root 3 over 1, or root 3. And the final one, which we will not need to evaluate, it looks like 2 sine theta over 2 cosine theta over 2. This looks like our double angle for sine. So this is equal to the sine of 2 times theta over 2, which is equal to the sine of theta. All right, example 2. I want to evaluate cosine 2 theta and sine 2 theta, but all I know is that cosine of theta is equal to negative 2 over 3. First of all, let's work with that. So we have cosine theta is equal to negative 2 over 3, which recall is equal to x over r. And for this example, since our interval is from 0 to 2 pi, we have to look at two quadrants, quadrant 2 and quadrant 3. So we have x and we have r. And all we're missing is the y value for us to get our sine ratio. Well, for both of these, we know that y squared is equal to the hypotenuse squared minus negative 2 squared, which gives us plus or minus the square root of 5. And you can see for the one graph, this would be positive root 5, and for our second graph, this would be negative root of 5. So therefore, sine of theta is equal to, remember that's y over r, so it's plus or minus the root of 5 over 3. So there are two answers for sine of theta. Now that we have both ratios, we can evaluate cosine of 2 theta and sine of 2 theta. So for cosine of 2 theta, we just need to pick one of the three identities. So I'm going to use 2 cos squared theta minus 1. So I get 2 times, and cosine is negative 2 over 3 squared minus 1. So 2 over 3 squared is 4 over 9, and times 2, that's 8 over 9, minus 1, which tells us that cosine of 2 theta is negative 1 over 9. And if you used either of the other two ratios, you should get the same answer. Let's look at sine 2 theta. This one's a little bit more interesting. We know that sine 2 theta is equal to 2 sine theta cos theta. So we have 2. Remember that sine theta is actually plus or minus root 5. There's two answers for that. Times cos theta, which is negative 2 over 3. So we have 2 times plus or minus root 5 times negative 2. So this is plus or minus 4 root 5 all over 9. Which means that sine of 2 theta actually has two answers depending on which quadrant you are in. So if we are in quadrant 2, it'll be the positive answer. If we are in quadrant 1, it'll be the negative. But notice that cosine is actually negative in both those quadrants, so that's why we only have one answer. In example 3, we're going to look at how to develop what are called the half-angle formulas. When developing the half-angle formulas, we will always use the cosine 2 theta identity. Since we're looking for a formula for sine of theta over 2, we're going to use the cosine 2 theta identity that has sine in it. So we have cosine 2 theta is equal to 1 minus 2 sine squared theta. If we replace the thetas with alphas, and then we let alpha equal theta over 2, then we get cosine 2 theta over 2 is equal to 1 minus 2 sine of theta over 2 all squared. Now we just need to isolate for sine of theta over 2. First of all, we can move the 1 to the other side, so we get cosine of theta, the 2's cancel, minus 1 is equal to negative 2 sine of theta over 2 all squared. Then you can divide both sides by negative 2, and I get cosine theta minus 1 over negative 2 is equal to sine theta 2 all squared. We get 1 minus cosine theta all over 2 is equal to sine theta over 2 squared. Last part, square root both sides of this equation, and don't forget your plus or minus. So we get that sine of theta over 2 is equal to the square root, plus or minus, of 1 minus cosine theta all over 2. And this is called the half-angle formula for sine. So for example, if we let theta equal pi over 4, then we get that sine of pi over 4 divided by 2 is equal to plus or minus 1 minus cosine of pi over 4 all over 2. This is the sine of pi over 8, which is clearly in the first quadrant, so we're going to take the positive square root, since the sign should be positive in quadrant 1. 1 minus root 2 over 2 is the cosine of pi over 4 divided by 2. If we find a common denominator, we get 2 minus root 2 over 2, again, all divided by 2. And finally, if we flip and multiply, or if we divide by 2, we get 2 minus root 2 all over 4 is equal to sine of pi over 8. That would be the exact value. Books will take this a step further and simplify again. In the numerator, we have the square root of 2 minus root 2, and since we can square root 4, then the bottom becomes 2. And there would be the exact value for the sine of pi over 8. And last, we're going to use a double angle formula, or 2, to develop a formula for cosine 4 theta in terms of theta. And there's many ways to do this. One way to determine cosine 4 theta is to rewrite it as cosine of 2 theta plus 2 theta. So that is 2 thetas. So using our cosine 2 theta identity, this is equivalent to cosine squared of 2 theta minus sine squared of 2 theta. So again, I used my cosine 2 theta identity, which is equal to cos squared theta minus sine squared theta. But I still have 2 thetas there. So I have a cosine 2 theta and another cosine 2 theta, since this is a squared, minus a sine 2 theta times a sine of 2 theta. And again, I just pick an identity. So for cos 2 theta, let's keep the same one. Let's use cos squared theta minus sine squared theta times cos squared theta minus sine squared theta. The next one is 2 sine theta cos theta. That's our sine 2 theta identity, times 2 sine theta cos theta. Okay, let's expand. If I expand the two brackets, I get cos to the 4 theta minus 2 sine squared theta cos squared theta. And again, you'll need to expand to see that. And negative sine squared times negative sine squared is sine to the 4 theta. And then if I expand everything on the right side, I get 4 sine squared theta cos squared theta. Okay, so this is all equal to this, and this is equal to this. Last step is just to simplify what we can. I still have my cos 4 theta, but then I have a minus 6 sine squared theta cos squared theta, if I collect all the sine squareds and cos squareds, plus a sine to the 4 theta. So now I have a formula for cosine 4 theta in terms of just theta. So for example, if I wanted the cosine of 4 pi over 3, if I put pi over 3 on the right side, I can evaluate what cosine 4 pi over 3 would be. Here are some examples that you should try. So here's a good thinking question. Solve this trig equation on the interval 0 to 2 pi, and notice the answers are there as well. Enjoy.